Hello everyone, welcome to my channel. Today we'll solve other some OPAMP basic questions. So let us start. First question is in the circuit shown below. This one, the voltage VI is 1 plus 2 sin omega t and VI2 minus 10 million. The output voltage is, so we have to find the output voltage here and the values of VI1 and VI2 as given. If you observe these circuits, we can take this circuit up to here, one circuit, and this is other circuit. So first we'll find the output of circuit 1 and output of circuit 2 by taking the output of first op-amp circuit to the input of the second op-amp circuit. So let us start the taking all the values. So first let me draw again solution. This is grounded. We'll take this is a V01, this is VI1 20k 2k. So nothing mentioned about the op-amp. So we'll, yeah, here this is the first circuit. Here nothing op-amp regarding op-amp nothing is mentioned. So we'll take op-amp is idle. So virtual ground concept will applicable. So here we'll get 0 volts. From this we'll get, it's a basic inverting configuration op-amp. So V01 by VI1 is equal minus 20 by 2. It's like minus 10. So here V01 equal to minus 10 times of VI1. This is output of the first op-amp circuit. Next we will take second op-amp. Final we will take for both op-amps outputs. I will substitute the input values. So second op-amp is it is 1k. Here it is coming from here. I mentioned this is V01. So this V01 is coming here, and this is VI2 is grounded, and we have one more 20k resistor. This I told V0. So this is 20k, this is 1k, this is 1k. So again this op-amp is ideal one. We can use the virtual concept. So 0 volts will appear here. So we'll apply the KVL. I will apply the node analysis here. So we'll assume this is V. So we'll write V minus V0 1 by 1k plus V minus VI2 divided by 1k plus we'll take V minus V0 divided by 20k equal to 0. By LCM we'll get all 20. So 20 V minus 20 V0 1 plus 20 V minus 20 VI2 plus V minus V0 equal to 0. So 20 V to 40, 41 V. Sorry, see 40 V is, I told we will apply V, but V is 0 only. So this will get cancelled, this will get cancelled, and this will get cancelled, means 0. So now we have minus 20 V naught 1 A2 equal to V naught. So from the output of first one we substitute here, minus 20 times V naught 1 equal to minus of 10 Vi1. So this is what we want, and minus 20 Vi2 into V naught. So here it is 200 Vi1 minus 20 Vi2 equal to V naught. So now we'll substitute the values. So then V naught equal to 200 Vi1 minus 20 Vi2, 200 times, so Vi1 equal to 1 plus 2 sin omega t, 1 plus 2 sin omega t in millivolts minus 20 times minus 10 in millivolts. This we will take millivolt common. So now let us solve this. So if it is 200 into milli, 200 plus 400 sin omega t minus or minus plus 200 is millivolt. Now we will see the answer in which format it is there. So here it is. Okay, we'll take 200 and 1 point. We'll take 400 common. 200, 200, 400. 400 means we'll take out common 400. Means 1 plus sin omega t in millivolt. We want in 400 millivolts, but it is 0.4 times. So we'll in microvolts it will come. It is like actually it is 0.4. It is not in millivolts. V naught is 0.4. So here it is 0.4, 1 plus sin omega t. So this is our answer for this question. So here mainly you take out one circuit output and that connected to the input of other circuit and solve the problem. So for our question, answer is 0.4 sin 1 plus sin omega t in volts. Yeah, we'll move for next question. This is also one more interesting question. Here they are asking find the I naught of the circuit. If you see this circuit, here on we solve. So here it is I naught connected to the feedback is 6 kilo ohm resistor and one more feedback through non-inverted and 2 kilo ohm, and this is 6 amps current source. So this in the first lecture only I have explained the current entering into the OPAMP terminals is always 0 amps. Here it is 0, here it is 0. So this 6 amps whatever it is coming here, it will go in this way. So here find out, if you want to find the I naught, we should know this current as well as this current. So this I will assume as I1, this I will assume like I2. So if you see this current 6 amps, it's coming like this. So I1 I can take as directly 6 amps. We don't know I0 and I2. So for this one we will use the virtual concept again. So it is grounded here. So this path only connected here. So this is ground terminal. It's 0 volts. Here also 0 volts. I will apply the node here. So I will apply node here. I take V. So now V minus V naught divided by 6K, and the current entering at this terminal I will take as a minus 6 amps is equal to 0. We know the by virtual concept V is 0. So 0 minus V naught by 6 equal to 0. Therefore V naught equal to minus 36 volts. And V naught equal equal to minus 36. So we got the V naught here is minus 36. Actually this is 3 kilo ohm. So here we know the V naught. So this current we can find this 0 and this is V naught. For their current I2 is nothing but V naught minus 0. This is simple one, what you call current equation. I2 equal to difference of these two voltages, this voltage and this difference, divided by 3k. So I2 is V naught equal to minus 36 divided by 3 means minus 12 milliamps. So therefore finally we have I naught equal to, I told I naught is equal to entering currents minus entering currents plus entering current I naught plus I1 and sum of the leaving currents I2. This is what we have to find. So we got I1 value and I2 value. I1, substitute this, I naught equal to I2 minus I1. We have I2 is minus 12 milliamps minus I1 is 6 milliamps. So answer is 30 milliamps. So I naught is minus 18 milliamps. So here mainly we have to see the current, how it is passing through the circuit. After 6 amps is coming here, we only one trick is we have to apply the virtual shorts concept here, then we'll get the V naught. So this is all about question 2. We'll move for other question. Till now we saw the questions which are in closed loop, means we applied the negative feedback to the OPAMP. We found all the output voltages at OPAMP. So this question is different. This mainly based on comparator circuits. Comparator. So we will solve one question regarding this. So we'll get the idea about how OPAMP can be used in open loop. I will give a little introduction about these open loop configurations. See, this is one schematic of OPAMP. Here we have negative terminal and now first terminal. Here we have plus Vsat and minus Vsat. Here we have V naught. This is minus Vsat. This terminal is plus Vsat. This is one terminal V1. This terminal V2. The OPAMP can work in open loop is like when V2 greater than V1. That cases output V naught equal to V2 is connected at inverting non-inverting terminal. So that time if you give the input more than this input at non-inverting, we will get the output is plus Vsat. Suppose when V2 less than V1 mean the voltage at non-inverting terminal is greater than the inverting terminal. That case we will get output equal to minus Vsat. So this V1 and V2 can be anything, whether it is 2 volts or 0 or sin omega t or it is 0, whatever we can. This is the main concept in the when you apply the open loop configuration of the OPAMP. So now we will move to this question. So here also they have given input to the positive terminal and some voltage given at this terminal. That is input they give a sinusoidal voltage of peak to peak 8 volts peak to peak they are given without any DC. Then output of the comparator duty cycle. Yeah, I want to tell 1 minute about this duty cycle. See, duty cycle is nothing but on time of the waveform to the on time plus off time. So T on divided by T total. In total time period, if you take this is one waveform of the square wave, this is total T total in that how much time it is on. This is t on, this is t off. The duration here, it is how much time it is on, that will calculate by using the t on, and the total how much time it was on, this will calculate from the t total. By using this formula we'll get the duty cycle of the any waveform. So duty cycle, it is the duty. So here they are asking the duty cycle. So duty cycle is for this particular op-amp, what is the duty cycle they are asking. So we will input is here it is giving it, see I told the input is giving it the non-inverting terminal of the op-amp. So whenever this input greater than 2 volts, it will go, if input is greater than this terminal, output is Vsat. We will take, so here I will take this. Okay, let me take this is the in. So this I will consider as input, this I will consider as V0, and this is T, this is T. So first the input, it's like this. Here they mention this is 8 volt peak to peak. So in that case peak is, we have 4 volts. So this is input Vi equal to, this is input they are given, and they are comparing with 2 volts, 2 volts reference, 2 volt reference. Somewhere it will be like this. So 2 volts it is reference. So we have, here it is, two volts, here it is, no it is only 2 volts they are comparing. So whenever input greater than 2 volts, what is happening, we have to see. Yeah, when our input is greater than 2 volts, input is greater than 2 volts, input is greater than 2 volts, it is dominating the positive terminal of the op-amp. So output is plus Vset. So whenever input greater than 2 volts, output is plus Vsat. So if you take like this, I am not able to draw correctly. I mean the plus space is very less. So whenever output greater than 2 volts, it will go to plus Vsat. When input is less than that one, it will come to minus Vsat. And this cycle will repeat again. So it will be like this. Whenever again greater than 2 volts, it will go to plus Vsat, and it will be like this. So here we should know what is this angle. We should know what is this angle. We should know what is this angle. So how we will come to know is 4 sin omega t whenever it is crossing the particular reference 2 volts. So we have, I will take this is theta. So sin theta equal to 1 by 2. So theta equal to 30 degree. So this angle is 30 degree. So this is 130 degree, and whenever it is coming here, this is 30 degree. So theta equal to 30 plus 30, the total 30 plus 2 theta now. So we have 60 degree. So what is, I told you on time you require, this is on time, remaining full time is half time. So in on time we have to calculate this total 180 of the cycle minus this 60 degree. So we have 120 degree, this is on. T total is 360 degree, correct na? So I'm measuring whenever this is off and this is off time. This I want only this on time. In full cycle it is like this, only this time only it is on, this time only it is on, this time only it is on. So this only the angle of 120 degree. So here, so now we will calculate the duty cycle. Now duty cycle is T on divided by T off. T on is we have 120 and T off, T total is 360 degree. So we have 1 by 3. So this is the answer for this question. Here is mainly you have to see how much time it is on and when it is on. So here reference is given 2 volts, that's why I made like this. No, this and all no need to made in exam. Directly we will take 2 volts and here you will take, and T on will calculate like this, and the T on divided by total time will get the duty cycle is 1.3. This is correspond to 33.33%, means less than 50% of the duty cycle. So this is all about a open configuration of the OPAMP circuits. So we will move on to next question. Yeah, here also the OPAMP connected in the open loop. So as I told, if it is V positive terminal greater than V, we have V positive terminal of OPAMP. See, the question is the circuit, in the circuit when the LED will glow, and for that one when will be the, for that one what is the value of Vi. Here is Vi, here it is value, and when this can be glow. So basic LED touch LED, if you see when it will glow, we can have some resistor we connect here. When you give plus volt here, this can be grounded, that time LED start glowing. See, this is some R, so that time current will pass and LED will glow. So that's what we want here, plus V, so that LED will glow. He is telling LED in the circuit will be on, Sometimes it can be, here they can twist, the LED in the circuit will be off if Vi is, like that also they can ask. In this question they asked when will it will be on if Vi is, they're asking less than 10 volts or less than 5 volts or greater than 5 volts or greater than 10 volts. Now we will solve. So idea is here how much voltage it can be on. So by taking this circuit, see here it is, will we will solve here only. If you see this, so here we want Vi. When Vi is greater than this voltage, this value assume like some Vx. When Vx greater than Vi, output will be what? This is non-inverting, inverting, this is non-inverting. Vx is greater than Vi, what will happen? Output will be minus Vset. When it is minus Vset, LED will not be glow. So that case LED is off. LED is off. Now next case, when Vx greater than Vi, sorry, Vx less than Vi, this Vi less than this means this is dominating, so that time output will be V naught equal to plus Vsat. So as for this condition, if it is positive voltage and ground here, current will pass like this, so here also we'll get LED is on. So this case we want when the Vx is less than Vi, we have to find this voltage. So see here the simple is, if you say terminals current entering into the op-amp always 0 amps. So here it is normal KVL or voltage divider we can apply. If you apply the voltage divider, what will get? Here it is simply 10k. Here we have 10 volts. This is 10k and this is 10k. Here we want Vx. Is nothing much easy, not 10 into 10 divided by 10 plus 10. So we have 5 volts here. So we have, see here we have now Vx I got 5 volt. Now you tell me when Vx greater than 5 or Vx less than 5, LED is on. This condition we want. So when Vx less than Vi, LED is on. But the question is asking when will the Vi? So Vi should be what? Vi should be greater than 5 volts, means Vi greater than plus 5 volts, LED is on. That time it will go. So this Vi greater than 5 volt, we have to see the condition. This is only our main object. The question. So if you see this one. So LED, sorry. So Vi greater than 5 volts. This Vi greater than 5 volts, it will dominate. We'll get plus Vsat here, and current will pass like this. LED will glow. So answer for this question is Vi. It should be greater than 5 volts because it is at this terminal. So this answer for this question is 5 volts. Thank you all.